In chapter number 12, we're going to spend a lot of time talking about extratropical cyclones. Another name for these is mid-latitude cyclones, or simply low-pressure systems. In Aaron's Today, Meteorology Today book, the 11th edition, reading assignment pages 319 to 335. We will split this particular chapter up into 3 different videos. It's pretty extensive. In the first video, we'll talk about the polar front theory. We'll talk about a term called cyclogenesis, and then we're going to take a look at some of the common cyclones and put some names to them, like the Alberta Clipper, the Colorado Low, and the Nor'easter. When we get into the second video, we'll talk about things like convergence versus divergence on the upper level charts. We'll take a look at the vertical structure of the low pressure system, and we'll split out the difference between upper level waves, the long wave, and the short wave. And then when we get into part 3, we're going to talk about baroclinicity, in other words, the baroclinic wave theory. We'll tie in the jet stream and how it affects the development of low pressure systems and how they aids in the movement of surface pressure systems. And then we'll end it with a little bit on some case studies to tie it all together. So the first part of this chapter will deal with the polar front theory. This is showing us how low pressure systems evolve over time from the beginning stages to the mature stage and then to the dissipating stage. Now note the time frame. It's after World War I. It was basically developed by meteorologists from Sweden and Norway. The time frame for World War I was in the 19 teens, and so just over 100 years ago. So modern day meteorology basically got its start in this time frame. Now we didn't have any upper level support. This polar front theory is all based on just surface data gathering, and once we had communications and we could gather data at the same time for a specific area, then we could start analyzing it, and we came up with this polar front theory. So this is what we're going to look at, these 6 different panels, and we'll talk about each one, and we'll see how these lows evolve and dissipate over time. So in the first panel, we call it the polar front. We have a stationary front separating 2 different air masses. Let me bring up the drawing utensil. We have 2 high pressure systems, each with their own identity. We'll put a continental polar up here and a maritime tropical down here. Wind fairly parallel to that stationary front, and since we don't have any movement of the air masses, we will put that stationary front in there to separate those 2 different air masses. Now the second phase, the frontal wave. Now you can see we have the beginnings of a low pressure system. We have one closed isobar. The air masses will start to move now that we have counterclockwise rotation around this low pressure system. The leading edge of the cold air push, that's where we'll put the cold front, and as the colder air recedes in this area and the warm air can filter in, that'll be the leading edge of the warm front. We know that the low is developing because the surface pressure in this area is decreasing, which indicates the developing low pressure system. The open wave, the central pressure will continue to lower. If you go from like 1,000 millibars down to 996 millibars, that is lowering of the surface pressure, which means the low is intensifying. The wind speeds will increase. The isobars, we have more of them now closed. They are also closer together, and so the pressure gradient is increasing, which is indicative of higher wind speeds. Precipitation pattern has developed, so we do have enough water vapor to create precipitation on the north side of the warm front and along and just behind the cold front. And we also have a well-defined warm sector located in between the warm front and the cold front. So this is the open wave. Next, this is the start of the occlusion. So this is when a low pressure system will achieve peak intensity. It will have the strongest winds, the lowest pressure reading in the middle, and the heaviest and maybe the geographically the largest area of precipitation. Now it's hard to see, but the cold front has just caught up to the warm front, and so right in here we just got a little bit of a speck of purple indicating the start of the occlusion. So this is, again, peak intensity for this storm. So once you achieve peak intensity, then you got to start to go the other way. So those low starts to weaken. A triple point is observed at the intersection of the three fronts, and that is located right here. So we have the occlusion, the cold front, and the warm front, so that's what we call the triple point right at that location. A secondary low could develop on that particular spot as this particular low decreases in intensity. So why is it decreasing in intensity? Well, colder air is now being pulled into this direction, and it's being wrapped into the center of the low pressure system. The colder air is heavier, so therefore that's going to help increase the central pressure, which should mean that the storm is dissipating. Also, the warm sector, which also had the warm air and the moist air, is being cut off from the center of this low as the cold air wraps around and into it. And so we're also losing our moisture content into the center of the low as well. And in the last phase, you can see that the low is continuing to dissipate, and we lost our identities of the various air masses, so you don't see any warm, cold, or occluded fronts coming out of the center of the low. And what happened is we reestablished a stationary front, as this whole area has basically been mixed together and is just now considered a modified air mass. And then down here maybe we have another maritime tropical in play, and so back to the stationary front. So the importance of these features, let me just back up a couple, is we have to have these low pressure systems on the surface of the earth, because this is one of the mechanisms that will take cold air and warm moist air, and in this case over here cool moist air, so maritime polar, maritime tropical, continental polar, and as these things turn counterclockwise, they will mix all of these air masses together over time. So can you see what the low pressure system is doing? It's helping to balance out the budget of having not enough incoming solar north and too much incoming solar south. So the radiative budget that we talked about in earlier chapters, these low pressure systems will help neutralize the difference in temperature being too cold north and too warm to the south. So the earth has to have these to help balance out that difference in the way the earth surface heats. Okay, moving on. So the art of forecasting is, one part I should say of forecasting is when these low pressure systems are in your vicinity, you have to know a couple things. Number one, what stage of development is the low pressure system currently in? And if it's a well-developed system like an open wave, what quadrant of that low pressure system will your location be located in? To give you an example, let's pick on this open wave here in the mid-Atlantic states. So I'm just going to draw a line right through here. So now we kind of have four quadrants to that low pressure system. Now as we advance through this chapter, we'll cover some of these things I'm talking about. Now if you're up here in this area, and I just put a dot over Cape Cod, Massachusetts, you'd most likely have cloudy skies and a precipitation event because you're on the north side of the warm front. So a little bit of overrunning is going to be occurring in that area. If you're located back here, if it's a wintertime scenario, you're probably having a significant snow event, and with good winds you could be having a snowstorm or even a blizzard in the northwest quadrant of this low pressure system. This area, you got this high pressure system pulling air in through here, so you might be in what we call the dry slot in this area as that continental polar air gets pulled into the center of the storm. This area, that's the best part of this system. That's the warm sector. So it will be a nice air mass on the warm side, but you'd have to pay attention to this cold front that's going to be moving through your area, because that cold front could trigger enough upward motion to cause a line of thunderstorms to form as it advances towards you. So you can see how the various quadrants of this low really do differ. So as forecasters have to understand, as it moves through your part of the country, which area of that low will you be in to make a decent forecast for you. Okay, cyclogenesis. Remember we had frontal genesis. That was the creation and or increasing of intensity of a front. So cyclogenesis is the start and or increasing of strength of a low pressure system. So typical formation locations are the leeward side of the Rocky Mountains. We can talk about Canada. We'll talk about the Alberta Clipper. In the United States, we'll pick on the state of Colorado, the Colorado Low. We'll take a brief look at the Gulf of Mexico and where a low pressure system can form. The Mid-Atlantic coastline off of North Carolina, Cape Hatteras Low. And then the term bombing. TV meteorologists like to get a little bit excited if they hear this particular term. If the central pressure of a low pressure system is falling rapidly, and in this case 24 millibars in a 24-hour period, they'll call it bombing or bombogenesis. So that I know some TV meteorologists, especially during the winter season, like to use this term. If we have a low pressure system moving up the east coast and it's developing rapidly and it's undergoing this criteria, they'll say, look out, the low pressure is bombing, and they'll give you a heads up that expect rapid weather changes as that low pressure system approaches your area. Now here are some of the favorable regions for the development of low pressure systems. The Gulf of Alaska low, that's going to form off of the Aleutian low that we talked about in the global circulation model. It will work its way into the Pacific Northwest, but then it has to encounter all the various mountain ranges. So as it works its way into the northern and or central plains, there's not much left to it because a lot of the moisture was utilized as it went up and over the various mountain ranges. The two systems that we pay attention to here in the northern and central plains is the Alberta Clipper and the Colorado Low. Both of these will start their initiation on the leeward side of the Rocky Mountains, and then they can pick up in speed and work their way through our part of the world. I will cover both of these in greater detail in a little bit. Now the Arkansas Low and the Gulf Low and the Hatteras Low, they will not affect the northern plains because they're too far south and the trajectory will take them off to the northeast. So we here in Grand Forks will not have to worry about these systems, but if you're along the East Coast or the southeastern states, obviously you're going to have to pay pretty good attention to these particular systems. And then some of these can, they'll change the name also. We'll talk about a system called a nor'easter, and some of these will start off as the Gulf Low or the Hatteras Low, could actually become what we call a nor'easter. So why we have development along the leeward side of the Rocky Mountains, it's due to this phenomenon. The jet stream flow pattern will be perpendicular to the mountain range. Air on the leeward side tends to curve cyclonically, counterclockwise. The trough of low pressure develops at the surface, and so we call this process lee due to the location on the leeward side of the mountains, and cyclogenesis, the beginnings of or increasing in strength of a low pressure system. So lee cyclogenesis. So here's a Colorado low, and I put a black line on there to show you the jet stream flow pattern. The jet stream was coming over the Rockies. The low pressure system initially formed over here in eastern Colorado. Now you don't have to use the state of Colorado. It could be Wyoming, it could be New Mexico, it could be the Texas Panhandle, but somewhere along the leeward side of the Rockies. And then it will move out into the plains. It'll be able to pick up moisture from the Gulf of Mexico, and then depending on the jet stream flow pattern, that'll determine which way it's going to travel. So in this case, this low is going to be moving north-northeast. The best chance, if we're in a winter scenario, the best chance for snow would be on the northwest side of this particular feature. Now Grand Forks, we're way up here. Fargo, pick on Watertown, Sioux Falls, in that area. So as this thing was tracking in this direction, there was a pretty good snow event on the backside of this particular system. Now it did, Waupun in North Dakota had a significant snow event. Fargo was on the northern edge of the event. Grand Forks was just a little bit too far north and a little bit back too far to the west to get in on any significant snow with the movement of this low pressure system. But all of eastern South Dakota and a good chunk of west central Minnesota did have a significant snowstorm with the movement of this Colorado low. Now while we're having a snowstorm up here, there could be a significant line of thunderstorms forming along this particular cold front, which could be severe in nature, and then you have a lot of precipitation occurring in this area as well on the north side of the warm front. We again will cover a lot of these details in the remainder of this chapter. So give you an idea on these mid-latitude cyclones, we'll take a look at a case that occurred on November 18th, 2016, and I'll show you a little bit of motion to help you out. So on November 18th, 2016, the low pressure system was located. Now I'm not looking at the surface, I'm looking at 925 millibars. So in our part of the world, that'd be about 1,500 feet above ground level. But we had a real nice warm sector here. The warm front I denoted with a red line. A lot of higher relative humidities to the north of the warm front. And then here's the cold front, and we had very strong temperature gradient on the backside of the cold front. So warm air and the colder air was located in this spot. This blue line indicates 0 degrees Celsius or 32 degrees Fahrenheit, and this line up here is -5 degrees Celsius. So the chance for snow would obviously have to be to the north side or the west side of the freezing level at the 925 millibar level. So with this system, the Weather Service computer models put out a significant snow event for southeastern North Dakota back into a lot of central and eastern South Dakota. Now this is liquid, so it wants to go for about 0.86 of liquid. So that would accumulate to about, let's say, 6 to 10 inches of snow in that particular area. Now this was on November 18th of 2016, so a pretty good snow event before Thanksgiving week up here in the northern plains. Okay, next I want to show you is some motion with this Colorado low from March 23rd through the 24th of 09. So the first picture that we will take a look at will be enhanced satellite imagery. Now I can't show you visible because this is going over a 2-day period, so it'd be alternating between daylight visible versus nighttime where you can only use infrared imagery. Point out a few things before I start the movie loop. Number one, the low pressure system initially is going to be on the Nebraska-South Dakota border. The darker blues, that's the higher cloud tops. Where you see the bright oranges, that's basically clear skies and the surface of the earth. So features that you'll see, the cold front will be located in this vicinity here where we have thunderstorm development. This warm front's going to be moving off in this direction, and this will be the northwestern side of the storm. So this will be where we expect significant precipitation to occur as well. So here we go. So you can see the whole thing turning counterclockwise. You can see the thunderstorm development out ahead of it, and then you can see how this stuff wraps around the backside of the low. Now there's one other thing that's going on with this particular system, and that is this is what we call a dry slot. It's moving right up South Dakota, here it's moving up in the Southern Valley, and then it's moving right through Grand Forks. And so that dry slot cut our precip off for a while until we get another surge coming in out of the southeast. The area that I'm going to want to pay the closest concentration to on is the radar. And if we take a look at the greens and yellows, that's where we have precipitation. We see the darkness, that is no precipitation. So as we work through, first thing we can note is we had precip in Grand Forks here, but then the dry slot worked up and there it cut us off. Now we're in the drier air back through here. And then at the very end we get another surge coming in from the Minneapolis area working its way up to from the southeast, and we get into another precipitation. But what really want to show you is the forecasting of precipitation with these features is difficult because there's such a fine line between heavy precipitation and no precipitation. So if we go over here, Williston, you never see any green color over that area, but you continuously see green color through this area. And notice that sharp contrast right through here at all times. So when you take a look at total precipitation for this particular period, let me run through just one more time. You see where I put the cursor? You always have precipitation. It's always going on in that area, and it's never going on in this area. So when this storm was all said and done, see that strong cutoff? So from here, and now the units are in millimetres, but you went from the red area through here, you went from 50 to 75 millimetres. Here is about 50 millimetres, to here, nothing. So what actually happened, and it was cold enough in this part of the state to be snow. Williston did not receive any snow. Minot, just a little bit of snow. Beulah-Hazen area, 2 feet of snow. Bismarck-Mandan, 2 feet of snow. So from this point here to this point here, they had a dramatic change in snow depth in about a 40-mile distance. Now this next example on March 2nd through the 4th of 1966. This probably is why I'm a meteorologist today. I lived in Devil's Lake, North Dakota at that time, and I was only 8 years old, but man, what an influence it had on me. Obviously we missed school for about 4 days, 3 days because of the snowstorm and another day to dig out. And the winds are blowing so hard that these snow totals are basically just estimates, but Devil's Lake about 30 inches of snow. So what I'm getting at is some of these Colorado lows can last for an extended period of time. In my 60 years of living in this particular area, this is the worst snowstorm that I've ever experienced. Here are some of the pictures from that particular event. The snow was mixed in with dirt from the fields, and we call that snert, and so it got rather compacted, and so you can see that the snow was as high as the telephone poles back on that particular date. You could walk right up and over these telephone lines. The snow compacted up against houses. You literally could walk up the snowbank onto the roof of your house. This particular individual is going to do a little bit of skiing. He's got his skis on. He's going to come down that slope. We had to physically rescue people from their second-story windows, as in this case, because the house was encased in snow and they couldn't get out their lower windows or the front door. So they had to come out through the attic in some situations. In transportation, trains were buried in the snow. This locomotive, and we had to dig them out by hand. You can just see how devastating this particular event was. We got a snow blower on the front end of this particular vehicle, but the snow drift is just as high as the vehicle. So it took a little bit of time to dig out of this particular snowstorm, and yes, cars were completely buried as well. So the pictures that you're looking at are all coming out of northeastern North Dakota and northwestern Minnesota. There is a book written about this particular storm. I believe the name of the book is Candle in the Window, and Ramsey is the last name of the author. I can't remember the first name. I think I want to call it Doug Ramsey, but I might be mistaken on the first name, if you're interested in seeing what we went through in 1966. Okay, and then the next one is the Alberta Clipper. Now these storms are named Alberta Clippers because they will form in the leeward side of the Rockies in Canada. So this is the province of Alberta. This one is Saskatchewan, and north of us is Manitoba. So these systems will form up there, and then they'll move in this direction. They'll move from the northwest to the southeast. Now these systems are going to be fairly quick in movement, and I'll show you here. See this unorganized area of low pressure system? Well, now it becomes a little more organized in southeastern North Dakota, but within the next time frame, which I believe is just 3 hours, look how far it's moved from southeastern North Dakota all the way over to Duluth. So they call them clippers because of their fast movement, and the Alberta because of where they generate in the leeward side of Alberta in Canada. So this little case study, I did some analysis for you. We have a low pressure system in central North Dakota. We are in the warm sector, 25 degrees, winds out of the south, but you can see back to the northwest, the air is a lot colder and the winds have come around to the northwest. So this is, we'll round it up to 21 UTC. So being we're in standard time, that is 3 o'clock in the afternoon. So by the time we got to around 6 o'clock, the winds had switched to the north. So now we're on the cold side of the system, and the winds dramatically increased, and we have a band of snow causing 1/2 mile visibility. By 9 o'clock that evening, the temperature is now down to 6. This symbol is for blowing snow, and the winds are gusting to 31 knots. The low moving out fairly quickly into north central Minnesota. And by midnight, we're now at -2. The low is now over into Duluth, and the cold front's advanced all the way down into extreme southern Minnesota. So note how fast it moved and how fast the weather changed, hence the name Alberta Clipper. Now here are the METARs from that particular storm, and when we started out with this storm, the pressure was 1016.4, and it was rather warm with a temperature of 27 degrees Fahrenheit. Then the winds came around to a westerly component. Snow picked up, 1/4 mile visibility, light snow. The winds are now from 340 degrees northwest, gusting to 26, 1/4 mile visibility with moderate snow. And then the winds picked up to sustain to 27, gusting to 34 knots out of the north-northwest. And now we have 1/2 mile visibility with light snow and blowing snow. And by the next morning, again, we started at 27. The next morning, we're at -10 degrees Fahrenheit, and the pressure started at 1016.4 millibars, and now it's at 1032.6 millibars. So quite a rapid increase in pressure as the Alberta Clipper moved off and a high pressure system moved in. So here's the band of snow associated with that particular feature. And again, this is all quick. So Alberta Clippers are noted to, if they create a snowstorm, they'll be short-lived. In our area, maybe 6, maybe 12 hours, somewhere in between 6 to 12 hours. Not noted to get a lot of snow with these systems because they're moving fairly quickly, and since they come in from the northwest and move to the southeast, they don't have a chance to pick up significant moisture from the south. So you may have 2, 3, maybe a 4-inch snow event with these particular systems. So here it is as the cold front moves through. We get that band of snow with the frontal passage, and then it keeps on moving quickly to the southeast with the advancement of that particular cold front. The snow quits in Grand Forks, still snowing quite moderately in Fargo. Doppler can pick up the moving snowflakes, so initially the winds were westerly, and then as the cold front passes, the winds start to come around, and now the cold front has passed through. Now we have a northwest wind, blue toward the Mayville radar site, red away from the Mayville radar site, located right there. And the intensity of the winds increased as the dark blue is coming towards at 36 to 50 knots, and the red is going away from the radar site at 36 to 50 knots. So we have a north-northwest wind with fairly strong winds. So that's the makeup of the Alberta Clipper. And then if you do live along the eastern seaboard, you might tap into a Gulf low or a Cape Hatteras low. And as it's moving up towards the northeast and intensifying, they may flip the name on you to a nor'easter. So this can bring heavy snow, sleet, rain along the strong northeast winds along the east coast of the United States. Causes extensive damage along beaches, beach erosion, and possible damage to homes and overland flooding. Now the track of these, the center of these lows is critical to get the precipitation type forecast correct. If it does track out over the open waters, the center of the low, then all these major areas along the east coast can get a pretty significant snow event. If the low tracks right along the coastline, then the major cities right on the seaboard will most likely see rain, and the heavy snow belt will shift a little bit back further to the west. So meteorologists have to really pay a close attention to exactly where the center of that low pressure system is going to track to get the precipitation type and the snow total forecast correct. And one last thing before we take a break here is I've been talking about low pressure systems, but high pressure systems also are moving about the surface of the earth, and the purple arrows kind of show the general direction of movement of high pressure systems. Now the one thing to note for our area is even though these lows that develop down in these areas, they don't influence us as far as the precipitation that they can generate. But all of these low pressure systems need cold air ingested on the backside as they pull in the warm air on the front side. So as they move in this direction, yes, they're going to pull in the warmer air out ahead of them, but they got to pull in the cold air on the backside. And that cold air, unfortunately, has to go through us before it gets to them. So that's another reason why good old Grand Forks and the Northern Plains, we're going to have more cold days in the winter than we will warm days, because any low of significance that forms to the south and southeast of us, it's going to be pulling that cold air through us to get to them. Okay, that's enough for the first video. We'll cut it short there. Video number 2, we'll pick up with the topic of convergence versus divergence.